Hey, hackers and tech enthusiasts, welcome to Protocol, the series where we unravel the history and mysteries behind the technology shaping our digital world. I'm your host, Dade, and today we're going to talk about everybody's favorite scapegoat, domain name system, or DNS. DNS is the protocol that allows us to use human memorable names to access resources on a network. Without DNS, we would have to have a whole lot of IP addresses memorized to access our favorite services. For instance, instead of typing youtube.com into our browser, we might have to type 142.250.189.206. Definitely not as memorable. This behavior is why some people will refer to DNS as the phone book of the internet. But I suppose that these days that analogy might need further clarification since phone books were on their way out of popularity while I was growing up. Basically, the phone book was a book of nearly every phone number in a geographic region mapped to a corresponding name, just like how DNS maps domain names to IP addresses. But dated analogies aside, what is DNS and why is it so essential to how the internet works today? I wanted to dive into terminology next, but realized that it's kind of difficult to explain some of the terms without first explaining the very basics of DNS. At its most basic, DNS is simply a question and answer system. A client asks a question, and a server responds with an answer. So my computer might say, "What's the IP address for youtube.com?" And the server that it asks will reply with an IP address that serves the YouTube website. With that out of the way, there are a few key pieces of jargon that you should be aware of if you want to at least have a conversational understanding of the technology. The first term we'll cover is record. Think of a DNS record as an entry in the phone book analogy. It's essentially just a map of a DNS name to some value. Records have different types, some of which we'll cover a bit later on. The next term is a zone. For now, we can just think of a DNS zone as a collection of related DNS records. Next, we need to know what a name server is. Name servers are the servers that are ultimately responsible for telling us the answer when we ask for a record. Finally, a resolver is a process or service that knows how to query at least one name server and provide an answer back to the program or system that's asking. DNS has many critical roles in the modern internet. We've already talked about how it's responsible for name resolution, but it's also responsible for the hierarchical structure that allows us to group domains and query any domain name without knowing anything about how to contact it ahead of time. On top of the functionality of DNS itself, it's also become responsible for a variety of things around the web. If you need to verify that you have control over a domain, you might use a TXT record. If you need to send and receive email, you'll use an MX record. There are even cryptographic systems like DKIM that use DNS to cryptographically verify the authenticity of sent mail. Speaking of TXT and MX records, I mentioned that we'll cover some different types of records earlier. TXT and MX are just two of the common record types that you're bound to encounter. There are a whopping 47 officially supported DNS record types, but for the purposes of this introduction, we can get away with only knowing a handful of them. Starting with the A record. These are the fundamental building blocks of DNS. The A record is the record type that converts a domain name to an IP address. But with IP addresses becoming more scarce, DNS had to adapt to support a new record type for IPv6 addresses. We'll cover more about the differences between IPv4 and IPv6 in another episode, but for the purposes of DNS, the only thing that matters is that IPv6 addresses are 4 times as long as IPv4. So DNS came up with the cleverly named AAAA record, representing the 4x multiplier on the length of the IP4 address. One of the next most common record types you'll see is the CNAME. The CNAME is just a record type that points one DNS name to another DNS name. For example, if you were to query for www.youtube.com, it would be a CNAME to a different domain, which would then have a bunch of A records that map to IP addresses. Your DNS resolver knows that when it gets a CNAME record, it needs to continue querying until it reaches an IP address. What about email? If you want to send an email to me, your mail server would need to know how to talk to my mail server. This is where the MX record, or mail exchange, comes into play. An MX record can point to an IP address or to another DNS name, so it behaves a bit like both A records and CNAME records in that regard. But it also has its own custom field called priority, which is used to indicate the order in which mail servers should be contacted in the event that one fails. Another super popular record type is the TXT record, as alluded to before. The TXT record is interesting because it just allows the association of arbitrary text to a domain. People have then built their own protocols on top of this arbitrary text DNS record, such as DKIM and SPF, both of which we'll cover more in later episodes. But you can just put pretty much any text you want in a TXT record. Finally, it's important to understand the NS record, or the name server record. This record is what defines the servers that have authority to answer questions about a given domain name. It's the record that says, hey, ask me when you want to know about example.com. DNS records all have a value associated with them called time to live, or TTL. These records tell clients how long they should hold on to an answer before attempting to query again. The client will then typically cache the response, which just means storing a copy of the data locally. This enables two useful things. First, it allows the resolver to respond right away without having to ask the network what the address is, which means everything feels quicker. Second, it reduces the load on the name server for popular domains because resolvers can ask only once every 10 minutes, or maybe every hour, or maybe even every day, instead of asking for every single request. We can probably do a whole video on all the details of the life cycle of a DNS query, but we'll stick to a quick overview for now. Let's say I want to visit example.com in my browser. I type it into the address bar and hit enter. My browser will ask the resolver on my computer if it knows the address for example.com. The resolver will either immediately respond with a cached value, or it'll go out and query another resolver or a name server. If it queries another resolver, that resolver might have the answer cached. This is common in networks because it means that clients can benefit from each other's DNS queries without having to go out to the internet all the time. If you and your friends are on the same Wi-Fi using the same DNS resolver, the question for example.com only needs to go to the internet once instead of once per client. If it doesn't query another resolver, then it'll have to query a set of special servers called the root servers. I'll do a separate video on root servers at a later date, but for now, they're just special DNS servers that your computer knows how to talk to. It will ask the root servers if it knows where to find the name servers for com, and the root servers will respond with the record for the com name servers. Then, the resolver will ask the com name servers if it knows the name server for example.com, and the com name servers will reply with the corresponding records. From there, the resolver will ask the name servers for example.com what the IP address is. Finally, my browser will establish a connection with the IP address given to me, and I can see the awesome content on example.com. This has been a bit of a simplification in order to serve as an introduction to DNS. For many of you, this will probably be all the DNS information you need for most of your career. But there are things we've glossed over, things we've simplified, and things we haven't even considered yet that make DNS an even more complicated system. We'll do many future episodes on DNS to build up a better understanding, but not for a little while. Do you have a protocol you'd like to see a video on? Or maybe you'd like a deep dive into DNS? Let us know in the comments down below. If you're interested in seeing more of this series on protocols, give this video a thumbs up and make sure you're subscribed so you can get notified when the next episode goes live. With that, I've been Dade. Stay curious and stay connected.